Now we are talking about logarithms and logarithmic functions. Very, very important part of our study, logarithms and logarithmic functions. First of all, let me define logarithms. So, definition. The log of x in base a is equal to y if and only if x is equal to a to the power y, where x is greater 0 and a is also greater 0, but our a can never be a 1. These conditions are very important for you to put into your mind. Let me quickly talk about what I call the golden rule. We know that 10 to the power 2 is equal to 100. That's a fact. We all know that. 10 to the power 3 is equal to 1,000. Very true. Now, please, whenever you are removing from exponents to logarithms, this is what you simply ask yourself. This goes to log of 100, that is the right hand side, is equal to, in what base? In base 10. You see, 10 is the base and is equal to 2. We call this the golden rule, even if we are moving from here backwards, which means this can also do that. So without thinking, we can also do the same for this one. We have log of 1,000 in what base? We are still in base 10 is equal to 3. And internationally, we agree that if the base is 10, we don't write it. So it means we will write this as log 100 equal to 2 and a log of 1,000 equal to 3. You can use your calculator to verify what we are saying. So in general, when we have a to the power x equal to some b, if you want to write this in log form, the right hand side, which is log b, we're taking log with the right hand side, and this side, what is the base? It's a. The answer is always x. So it means you can move from here to there or from there to there. Very, very important. So let us now look at what we call logarithmic rules or laws. Logarithmic laws. These are very, very important, and they also go hand in hand with our exponential rules. We should always know that log of a times b is the same as log of a plus log of b. Remember, for exponents, if we have a to the power x times a to the power y, this is the same as a to the power x plus y. When we are multiplying, we add the exponents. When the numbers are multiplying, we add the individual logarithms. Number 2, log of a over b is equal to log of the numerator, which is a, minus log of b, which is the denominator. Again, this goes hand in hand with a to the power x divided by a to the power y is equal to a to the power x minus y. Please remember these even from your exponential functions. Number 3, very, very important again, it's log of a to the power p in base c. Now this is very, very important because it can be written as p, you take your p down, which is the power, then you have your log of a in base c. So whenever we have something with a power and we are taking its logarithm, the power multiplies the log of the number given. And then we have number 4, the log of 1 is always 0. The log of 1 is always 0. Very, very important. And number 5, we have log of a in base b being the same as log of a in a base of our choice over log of b in the same base. Please take note of this as well. Very, very important for us to remember. Now, I am going to look at a few examples together. There are only 2 here, examples, but these 2 examples have got part 1, part 2, part 3. A, that's example number 1. And we are starting with A, and I read. Use the definition of logarithms to convert logarithms to exponential form and exponential to logarithm form. Write these equations in exponential form and solve for x. So I'm going to look at log of 81 in base x is equal to 2. We said using the golden rule, we can write this as 81 is equal to log is equal to 2 to the power x. That's what I said. Log 81 in base x is equal to 2. So it's 81 is equal to x to the power of 2. Now we can write this as a number to some power. This is 9 to the power 2 is equal to x to the power 2. So the powers are the same, therefore what is our x? 9. Very, very important for us to notice. Then part B, we have log of x in base 5 is equal to minus 2. So this is the same as what? We write down our x equal to what is the base? The base is 5 to the power minus 2. So what is x? 1 over 5 squared, that's 25. We are solving for x in each of these cases. After writing it in exponential form, we then solve for x. Part C, we are required to again solve for x. We have log of x squared plus 2x in base 2 is actually equal to 3. Again, to write this in exponential form, we take down the x squared plus 2x is equal to 2 to the power what? To the power of 3. The base is given that power. Now this is x squared plus 2x is equal to 8. So x squared plus 2x minus 8 is equal to 0. So it's x plus 4 into x minus 2 is equal to 0. So our x is equal to 2 or minus 4. We have solved for x. Our last example, which example 2? Write the equations in logarithm form and solve for x correct to 2 decimal places. We are in this case now going to use our calculators because we are solving for x to 2 decimal places. A says 5 to the power x is equal to 100. So again, I said to you, when moving from exponential to logarithms, you just take the log of 100. What is the base? The base is 5. This is equal to x. Then you take your calculator and you write your answer according to this question to 2 decimal places, which I'm not going to do. I know you can do it on your own. Part B. Part B says, we need now to have 25 is equal to 10 in brackets 1, 5 to the power of x. First of all, you need to divide both sides by 10. So you have 2, 5 is equal to 1, 5 to the power x. Now you take logarithms both sides. It's a log of 2, 5 in base what? 1, 5 is equal to x. Now just use your calculator. You will find your answer to 2 decimal places. Last item on example 2, it is saying 2 multiplied by 3 to the power x minus 3 is equal to 12. Now first divide by 2 is 3 to the power x minus 3 is equal to 6. At this point you can say your log 6 in what base? Base 3 is equal to x minus 3. So your x therefore will be equal to 3 plus log 6 in base 3. Again, use your calculator to get your answer. Thank you very much.